Welcome back everyone to section 5.2, the definite integral. Now this is where stuff gets a little bit complicated, and this is where a lot of people kind of shut down, so make sure you're understanding this. There's a lot more information about this online if you just Google it, but I'm going to do just the basics in this video. What is a definite integral? Well, before I get into that, let's go back to something we do know. The derivative of a function. Well, the derivative of a function represents the slope or the instantaneous change. The slope is graph, instantaneous change is a word problem, a real life situation. It can be calculated using any of the rules we've already learned this year. You can use the power rule, the product rule, the quotient rule, trig rules, your exponential rules, your natural logs, your regular logs. You have to do chain rule if there's an outside and an inside. We've talked about that a lot. That's differential calculus. But now we're into integral calculus. The integral of a function represents the net change over a given interval. It's the net change, and I'm going to underline the word net, and we'll talk about that in the next slide. That's what it means in words. What's it mean graphically? It's the area under a curve. And we can estimate the integral by using the RAM methods we talked about in class last time. Okay? Well, real quick, this is the symbol for an integral. If I put bounds on here and a dx at the end of it, this tells me between 0 and 4. This is now a definite integral. I know it's between 0 and 4, whatever this function is. It's the area under whatever this function is between 0 and 4. That's a definite integral. Okay, real quick, what's the difference between total change and change in an interval, or net change? Suppose you walk 5 steps forward and 3 steps backwards. 1, 2, 3, 4, 5. 1, 2. You like my graph? Your total change is, 1, 2, 3. That's a better graph. Your total change is 8 steps because it's 5 steps forward plus 3 steps back to get 8 steps. Good job, you passed first grade. But what is the change in 8 steps? Your change in 8 steps from your beginning point to your ending point is only 2. Because if you do the 5 steps in the positive direction minus the 3 steps because they're in the negative direction, you only get 2 steps. Integrals measure change in an interval. In other words, they measure net change. An integral gives you that answer. It's how much it's changed over time. I don't care what happened between the first step and the last step. I want to know how far you are from where you started. Net change. Net change. What makes this not just be 8? These 3 negative steps. Negative numbers mess up total change. How do we calculate the integral? There's a couple different ways. We can use an infinite number of rectangles. Obviously, that's not what we're going to do. But that's the calculus behind what we're doing. We're doing the limit as n approaches infinity of the area of rectangles. The calculus behind this is very, very complicated, and I'm not going to make you learn it because you don't need it. You just need to understand that an integral is an infinite number of rectangles. We can use a calculator, and I'll show you that in a second. Knowing how to use the calculator is huge, but only 50% of the test is the calculator. So you need to know it, but you also need to know it, do it a couple different ways. We can find a geometric formula that fits the reason, but it doesn't always work. And I'll show you an example of that in a second. The last way is we can use an antiderivative. That's the most common method, but it can get very, very complicated, and you'll see. Today I'm going to give you a really easy example, but we've done antiderivatives before, and you see how complicated they can get. So let's start with an easy integral on the calculator. What does this mean? This means the area under x squared minus 3x plus 5 between 0 and 3. The dx is there just to tell you what you're doing the antiderivative of. You're integrating x. And this year it's not that important because dx, there's only one variable, it's x. But as you get into higher level calculus classes, there's more variables. They throw a lot of variables together, so it matters. Graph the function, making sure you can see both sides. Okay? Y equals x squared minus 3x plus 5. Graph it, make sure I can see both sides. I can see 0 and I can see 3, so we're good. Second trace 7. So second trace, and if you notice 7 is the integral. Type in the lower limit, hit enter. Type in the upper limit, hit enter. So the left bound is 0, enter. The right bound is 3, enter. And look, it tells me the area is 10.5. I don't have a place to put this. The area is 10.5. What's the advantage? It's extremely easy to do. What's the disadvantage? What if you can't use a calculator? Okay? Know this. It's really easy to check your work with these. How about if we use geometry? Take a look at this equation, and I need a dx. What shape is that graph? What's a semicircle? It's a semicircle. So I want to know the area under the semicircle from -5 to +5. That's what this question is really asking me to find, the area under the semicircle. Can we calculate it with no calculus? Yes. Because the area of a semicircle, well, what's the area of a circle? The area of a circle is pi r squared. You got to know that. So then what's the area of a semicircle? It's half that. Did you know the formula for the area of a semicircle? Probably not. But could you figure it out? Probably. Find this, and again I forgot to write dx, using geometry. Well, area is 1/2 pi r squared. In this case, what's the radius of this semicircle? It's 5. So what's the area? 25 halves pi. I don't know how to do that problem without using geometry. That's a crazy problem if you don't know how to use geometry. But that's the integral of a semicircle. It's the area. What other shapes could I give you? Well, we'll talk about it in a second. But how do I do this? I sketch the graph, determine the shape created by the function, the bounds, and the x-axis, and I use a geometric formula. Yeah, you have to know some basic geometric formulas. One's like a rectangle is base times height. A triangle is 1/2 base times height. A circle is pi r squared. The big one, and one we're going to talk about here in a couple lessons, is a trapezoid. The area of a trapezoid is base 1 plus base 2 divided by 2 times the height. But a trapezoid in calculus is sideways. So the bottom is this way, and then the two sides. The two bases are really the y values, and the height is really the x value. The third way, the most common way, is using an antiderivative. So we're going to work backwards. Okay? It's the most accurate method, it's the most used method, but not everything can be calculated easy by hand. Next year, those of you that take me for BC Calculus or Calc 2 in college or Integral Calculus or whatever they call it, you will see this a lot. To evaluate a definite integral using antiderivative. So how am I going to do this by hand? No calculator, no graph, just sketch, or just doing it. Find the antiderivative. That's what we practiced in 4.8. Plug in the top bound and get an answer. Plug in the bottom bound, get an answer. Subtract the top bound from the bottom bound answer. This is called the fundamental theorem of calculus part 2. We'll do part 1 next time. Let's take an example here. This is a really simple example. Before I get into this, let me just do this with the calculator so I can get an answer. So what's the integral of 3x squared, second trace 7, from 0 to 2? The answer is 8. So we better get 8 for our answer. Step 1, do an antiderivative. What is the antiderivative of 3x squared? Well, raise that by a power, and you get x to the third. Put a 1/3 in front, but the 1/3 and a 3 will cancel. So the antiderivative is x cubed plus c. But I don't need a plus c because I know what I'm evaluating between. I know exactly what I need. So I don't need a plus c. I put this little thing right here to tell me that I need to evaluate it. But what are my two bounds? Well, the bottom one is 0, and the top one is 2. I need the top answer minus the bottom answer. If you plug in the top answer, what is 2 cubed? You get 8. If you plug in the bottom, what do you get? You get 0. 8 minus 0 is 8, which matches the answer I was supposed to get. Now that's an extremely simple antiderivative problem. And I don't want to spend a lot of time on this video going into it. We'll do a lot more in class. But if you have any questions, guys, about the idea, the concepts of it, just let me know. Come talk to me. We will do a lot of practice with antiderivatives. Other than that, thank you very much.